Hi, everybody. I hope everyone is keeping well, and I hope everyone enjoyed their long weekend. I know it was a long weekend. Doesn't seem like it. I'm going to get started with this stuff. So what's going to be happening is we're going to be talking about quadratics more so. Now, quadratics, I'm going to obviously go through what that is. It has to tie in with the notes that we did last week. And yeah, we're going to be talking about them, going into more detail. And then what's going to happen is I'm going to have, this note's quite short. And I don't have any practice problems for you for this one because tomorrow or the next one I'm going to do is quite big. Okay? Just so you're aware. Actually, I'm not even going to say tomorrow. I'm going to post both of them. So yeah, just so you know. And then what's going to happen is next week I'm going to have 2 more notes. So it's going to be the same idea. I'm going to post them. You guys are going to do your assignment on Friday. And then that'll be it for this quadratic stuff. And then next month, so June, which is only a couple weeks away, we're going to get into triangles. Okay? So, yeah, that's pretty much our roadmap for the rest of this stuff. I know this stuff can be kind of tricky, but again, guys, these are things that you're going to have to do in grade 11. Okay, so it's going to be complicated. Yes, I told you I'm going to tell your teacher. I don't know who it's going to be for grade 11 college, but I'm going to be telling Mr. Brzee, he's head of department. He'll remind that teacher, so on and so forth. Besides that, the other thing is, for those of you for the Remind Me app, okay, some of you guys might think, oh, that's so lame. You know what? I really don't care. Okay, I think it's just an easier way. I kind of wish I had it set up since the beginning, to tell you the truth, but I just had started it now. So yeah, if you could get signed up, I put all the information on Edsby for how to sign up with it. It's just an easier way for me to communicate with you guys. Besides that, just a reminder, if you're failing the course, you have to get that markup or you will not get your credit. Okay, so let's get into this. So, introduction to quadratics. So, what we're going to be talking about, so linear functions we've already done. Okay, that was a big chunk of the beginning of our unit or our semester, I guess. So, these are straight line. Linear functions are a straight line. Okay. So that means we'd use a ruler to draw this, because I'm sure all of you did that. Okay. Equations have x's and y's. Now, I'm going to go into a bit more detail about that in a bit, so that's going to be a bit more explanatory, but our basic equation of a line, which we've all dealt with, is y is equal to mx plus b. Sound familiar? Where this guy, what was our m? Our m was our slope. And our b, what was our b? Was our y-intercept. Okay, I'm hoping that is all coming back to you. And then the tables have first differences. And now we did that too. Now I'm going to go through that in a minute. If you guys forgot what that means. And it has to deal with our slopes too. But yeah, so that is an example of a linear function. So if I were to go, let's do this. Let's break out the ruler because we got to be all official. Okay, so if that's our Cartesian plane, and I were to have a linear function, let's say it looks like this. Remember? So if we were to look at our slope, we know our slope is our rise over run, right? So our slope, I can actually use the thinner one, would be our rise let's say, I don't know, it's 3, 1, 2, 3. Again, this is just rough, right? That's our slope. It's the degree of which this line goes up. And our y-intercept is where it crosses that guy, because I should label it, that's our y and that's our x. Okay? So again, this is just a general equation, so I'm just going to label it as y is equal to mx plus b. All right, I'm hoping all that stuff makes sense, guys, because this is old stuff. So our new stuff is graphs that are parabolas. Now, that might be a new word for some of you. So that means it's a U-shaped. Okay, so it looks like this. And we looked at this last week when I showed you a couple graphs with a couple little different things. Here, let me get Desmos up. Where is my Desmos? There we go. Okay, so linear equation. Let's say if I do y is equal to 2x plus 1. Oh. X plus 1. Okay, it looks something like that, where 2 is our slope and 1 is our y-intercept. And then if we were to have a quadratic function, it's going to look like a U shape. So it's that x is going to have a 2 on it, a squared, which you guys were doing when you were factoring last week, right? It was funny to putting it in the system. As I said, I'm not gonna take marks or anything off like that for you as long as you tried it. But yeah. So look, y is equal to 2x, let's say squared plus 1. As you can see how much of a difference that squared makes. So I'm going to go through an example with you to show you why it does that. And yeah, so this is the difference of what we're going to be, the differences of what we're going to be getting into when it comes to looking at a linear equation versus a quadratic equation. Okay, so hopefully you guys now can see the difference and you can see the impact of what that little 2 or the squared makes. Okay, so equations have x squareds and y's. Also, too, don't forget we were dealing with that standard form. So y is equal to a x squared plus bx plus c. Okay, so that's just an example, and the tables have second differences. Again, I'm going to show you what that means. So, example. Graph the following table using the table of values. So, these are base graphs. Okay, base graphs. That means they're the most basic that they could possibly be. Okay? These are the that means there's been no, they haven't been moved up or down, left or right. I'm trying to think if you get into I'm pretty sure you do. I'm 99% sure you do get into transformations in grid 11, okay, which is why you need to know all this stuff. So let's do it. So first one we're going to do is y is equal to x. Y is equal to x. So what does that mean? So we've done it where we've grabbed our equation and we've put it into the table. I'm going to get some different colors going just so we can see the difference. Let's use that nice blue here. So that means whatever y is, okay, I didn't mean to do that, but whatever. It's what x is. Y and x are equal to the same thing. So if y was yellow, x would be yellow. If y was 50 years old, x would be 50 years old. I know those are obscure examples, but yeah. So y is equal to x. Okay, well, what's x in my first case? Well, x is -3. So y is -3. Okay, well, in my next one, what's x? It's -2, so my y is -2. And it's like, well, what do you mean they're the same thing? Well, if we were to look over here at our graph, if x is negative 3, now I'm going to do some erasing just so the whole thing's not marked up. If x is negative 3, negative 1, negative 2, negative 3, remember this is my x, this is my y. Because x is negative 3, my y is also going to be negative 3. So remember, our point goes right there. That was ugly. Okay? So then if my x is negative 2, that means my y is negative 2. So that means just the points are the same thing. And that's the most basic graph that we can have when it comes to a linear line. Everything else, we move it up or down, left or right. Don't worry too much about if you don't know what I mean by that. So if x is negative 1, y is negative 1. So we put the dot there, right? We have to match them up. Okay, this goes way back to our basic training too, and I was getting you guys to actually plot this stuff. What was x, y, x, y? If x is 0, y is 0. So that's just all I'm saying here. Y is the same thing as x. X is negative 1, y is negative 1. X is 0, y is 0. X is 1, y is 1, 2, and 3. Okay? So, now that we have that, I can draw that line. So, I gotta make her... Try to do it as close as you can, guys. Again, that's exactly what I do. I try to go as close as I can. Ah. Oh no. I thought that would have stayed. Does that line up? Nope. Close enough. So then if you were to look at any point on this, like on this line, so if we look at, let's say this point, well, what's my coordinate? Well, here's my x again, here's my y. This should all be easy for you guys. 1, 2, 3, 4, 5, 6, 7, 8. So my x is 8. Because they're all equal, my y should also be 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it is. It's on that line. 8, 8. Okay, just an example, guys. I'm gonna get rid of this stuff just to keep her clean. Okay. I'm gonna label this y is equal to x. It's always good to label your graph. So it says find the first differences. So if you guys remember us doing that, what we had to do is we had to go our bottom up. So 3 minus 2 is equal to 1. 2 minus 1 is equal to 1. 1 minus 0 is equal to 1. 0 minus negative 1 is equal to, remember, double negatives. That turns, negative and negative turns into a positive. So that's going to be positive 1. Negative 1 subtract negative 2 is equal to positive 1. Negative 2 minus negative 3 is equal to positive 1. Okay? So this is helping us find our slope. We did this way back yonder. If you don't remember, go back to your notes because it's in there. Okay? So, if the first differences are the same, which they are here, oops. As you can see, the first differences are the same. That means the graph is linear. Therefore, graph is linear. Okay? So down here, what we're going to be doing is we're going to be getting a quadratic function. Now, how do I know that this is quadratic? Let's do that color. Why not? Well, up here, it said the equations have these squares. Actually, I know, sorry guys, I'm just being nitpicky here. It has these squares, right? Well, this has a square. It's quadratic. That's how it tells us. Up here, so you can see there's no number on the x. How many times have I told you if there's no number there, we know that there's a 1? Well, as you can see, if our first differences are the same, first meaning the number 1, our graph is linear. In this case, our second differences are going to be the same, and I'm going to show you. And look, there's a number 2. Ho ho, fancy dancy. Okay, so in this case, it might be a little easier with the numbers for you guys to understand what it means. So y is equal to whatever x is, but squared. So like it was before, y was whatever x was. Now there's a slight change. It's whatever x is, but squared. So what it is, it's y is equal to x squared, right? Well, what's our x? It's -3. So I'm going to type in, I'm going to just do equals -3 squared. Now, some of you might be able to solve for this right away. Some of you might need a reminder that that's going to be -3 times -3. What's -3 times -3? +9. Put it in your calculator if you don't believe me. So, my first coordinate is -3, 9. So, I'm going to go all the way up here to my graph. -3, 1, 2, 3, because I do my x first, up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Also, you know, 9 is less than 1 less than 10. You could have just used that guy there, too. Okay, I'm going to get rid of those to clean it up. Okay, that's our first point. Our next one. My next y is whatever x is, but squared. Well, in this case, x is -2. So, I'm just going to skip the x squared part. I'm going to sub it in where my x is. All right? Usually there's an x. But I subbed in this number here. Okay? So, if you need the reminder, that's going to be -2 times -2. Remember, the negative's in the bracket, so you have to carry it with you. What do I get? +4. Okay, so my next coordinate is -2, +4. -2, 1, 2, +4. 1, 2, 3, 4. That's my next point. We've only done 2 points, so we don't even know if this is going to be linear or quadratic or anything, because if we're just basing it off the points, you guys should say, well, there's a squared in it. It's going to be quadratic. Well, you're right. But okay, let's do her again. Now, this is the last time I'm going to write it out like this. -1, -1. -1 times -1, negative times a negative is a positive. 1 times 1 is 1. So, a -1, when x is -1, x is -1, my y is +1. Alrighty, let's keep going. 0 squared, 0 times 0 is just 0. So at this point, it's 0, 0. Cool. Okay, let's keep going. 1. So, x squared. I'm going to sub in this for my x. 1 times 1 is 1. So 1, 1. Oh, look at that. We're going back up. Going back up. Okay. 2 squared. 2 times 2. Oops, I wasn't going to do that for you guys. My bad. 2 times 2 is 4. So the next point is 2, 4. 1, 2. 1, 2, 3, 4. There's my next point. Got one more. 3 squared. 3 times 3 is 9. So my x goes first, 1, 2, 3, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, you don't need to put those dots in. Obviously, it's just for me to follow along. Alrighty, so that's it for the table, obviously, because that's the only space I gave. So now we have to connect those lines. Always go left to right. Actually, I'm going to just start from the bottom because it's easier to draw. Look at that. U-shape, just like we said with our parabola. So this is y is equal to x squared. So, first differences. If these numbers are the same, the graph is linear. Okay, so bottom top. 9 minus 4 is equal to 5. Okay. 4 minus 1 is equal to 3. So, right away, we know the numbers are not the same. Okay, because 5 and 3 are different. So this is good because we've already shown that this thing is not linear, okay? It's quadratic. Okay. 1 minus 0 is equal to 1. 0 minus 1. Okay, remember that's positive. 0 minus 1 is negative 1. 1 minus 4 is negative 3. And 4 minus 9 is negative 5. So as you can see, our first difference are not the same. So first differences are not the same, meaning we know it's not linear. Which is good because we've already graphed it. Okay, let's do it again. So second differences means we do the subtraction again. But we're going to use these numbers. 5 minus 3 is equal to 2. Okay. 3 minus 1 is equal to 2. 1 minus negative 1, right away, you should be like, oh, Miss B, there's double signage. Yeah, you're right. So what does that give me? It gives me a positive. 1 plus 1 is 2. Negative 1 minus negative 3, again, double signage. It's positive. Negative 1 plus 3 is 2. Negative 3 subtract negative 5. So negative 3 plus 5 is 2. So all of our second differences are the same. Therefore, it's quadratic. So this is just proving it to you guys, okay? This is all I'm doing right now is showing you the proof of it. So then later when we're looking at quadratic example, like quadratic equations, and it's like, well, how did you know it was quadratic? Well, this is why. Okay? Okay. There we go. So those were the first two examples that I was using with the base graphs, meaning those are the most basic that those graphs can be. Which again, I'm going to show you here, y is equal to x there's a straight line. If I were to tap on any point, you would notice that both of those numbers are the same no matter where I go, because whatever my y is equal to, my x is equal to. Here, y is equal to x squared. Okay, it's the same thing. Our first point was -3 and 9. Let's see if I can hit it on the dot, and nope. I don't know why it's so finicky that way. There we go, -3, 9. We had -2, 4. I was lucky. -1, 1. 0, 0. 1, 1. And you can see the rest there. Okay? So, what I'm going to do is I'm going to take you through another example. And we're going to show that it works not with just the base graph. Okay? And then we're going to go through these different characteristics here, which I'm going to actually go into more detail with the next note, but it's just more of an introduction. Okay? So with these questions here, I'm going to go through it just a little bit faster. So please be listening. So graph the following using a table of values. So again, by now, you guys should be able to take this point and be able to graph it. Because I taught you, this is my y-intercept, this is my slope. So I plot the y-intercept first, and then I do the slope. But I'm guessing a majority of you forget or have forgotten, which is fine. It happens with everything that's going on. Sorry, I'm just taking a water break. Oof. Okay, and but we're gonna do this. It says use the table of values. So again, if you guys forget, that's why I'm going through this. We're gonna, whatever y is equal to, it's 2x minus 1. So we're going to start taking this x and putting it in here. So it's going to be 2 bracket -3 minus 1. So right away you guys should be like, we're going to do 2 times -3 first. Why? Why are we going to do that? Because of bed mass. Oh, you guys are so smart. 2 times -3 is -6. -6 minus 1 is -7. So, first point, -3, -7. There you go. Pro tip, guys, if you want to go ahead and do this question, pause me, do the question, see if you get it, and then you can just fast forward and check to see if you got it right. And if not, rewind and be like, oh, where did I mess up or whatever. Really, really good learning tool. Okay, guys? Again, you're only as good as hard as you work. Okay, let's do it again, but for when x is equal to -2. Again, we have to do this first because it's bed mass. Two times -2 is -4. -4 minus 1 is equal to -5. Okay, so -2, -5 is my next point. -2, -5. Two times -1 is -2. -2 minus 1 is equal to -3. So our next point is -1, -3. Okay, now what is it when x is equal to 0? Oops. No. Okay, take 2. 2 times 0 is 0. 0 minus 1 is negative 1. So at 0, y is equal to negative 1. Now, just a quick recap. What we talked about earlier, our y-intercept, I used it as yellow up there, so I'm going to use it as yellow. We know our y-intercept is whatever our b term is. It's whenever x is equal to 0, which gave us minus 1, and it also crossed here. Okay, it's all overlapping. Like, these are all just different ways that you can do this kind of stuff. Just thought I'd give you the little reminder. Okay. 2 bracket 1 minus 1. 2 times 1 is 2. 2 minus 1 is equal to 1. So 1, 1. If you guys are having a hard time being like, how did you know that point was 1, 1? You should have been doing this graphing stuff in elementary school, and I gave you lots of practice on it. So again, reverse back. 2 bracket 2 minus 1. 2 times 2 is 4. 4 minus 1 is equal to 3. So we have 2, 3. And last but not least, 2, 3 minus 1. 2 times 3 is 6. 6 minus 1 is equal to 5. So we have 3, 5. Awesome. So, judging by this, I can use a ruler to connect all these dots. Sorry, obviously, you guys are going to probably be a lot more accurate than me. I know that's not perfect, but do what you can. So, what's this equation? This equation is y is equal to 2x minus 1. Okay, let's do our first differences. 5 minus 3 is equal to 2. 3 minus 1 is equal to 2. So far, so good. 1 minus negative 1 is equal to 2. Put in your calculator if you don't believe me. Negative 1 minus negative 3 is equal to 2. Negative 3 minus negative 5 is equal to 2. And negative 5 minus negative 7 is equal to 2. Okay, guys? So, this proves that this is linear because the first differences are the same. The graph is a straight line. And our x has a 1, even though it's not put there. Okay? Okay, next one. Now we're going to compare it to x squared minus 1. So, right away, you should say this is quadratic because of this guy. So, again, we're going to start subbing this number into our x's, okay? Then we're going to put this x into here, and we're going to solve its respective value. So, negative 3 squared minus 1. So I'm only going to write it out completely a couple times. Negative 3 times negative 3 minus 1. Again, according to BEDMAS, we have to do this first because multiplication comes before subtraction. Negative 3 times negative 3 is positive 9. 9 minus 1 is equal to 8. So, let's graph it. Negative 3 and 8. Negative 3, 1, 2, 3, up 8. Should be right there. Okay. Negative 2 times negative 2 is positive 4. 4 minus 1 is equal to 3. So my next point is negative 2 and 3. Okay, I'm not going to write out the squared part this time, guys. Negative 1 squared minus 1 is equal to, what's negative 1 times negative 1? Negative 1 times negative 1 is positive 1, because a negative times a negative is a positive. 1 minus 1 is equal, I'm going to do that over here, because I skipped that part, because I feel like it, is equal to 0. There's my next point. So at negative 1, 0. Negative 1, 0. I feel like I messed up somewhere. Why do I feel that? No, should be right. I think I messed up somewhere. That's okay. I'll find it. Okay. 0 squared minus 1. 0 times 0 is 0. 0 minus 1 is negative 1. So 0, we have negative 1. Oh, no, I'm okay. Never mind. Sorry, guys. 0 minus 1. 1 squared minus 1. What's 1 times 1? 1 times 1 is 1. 1 minus 1 is 0. So we have 1 and 0. 2 squared minus 1 is equal to 2 times 2. 2 times 2 is 4. 4 minus 1 is equal to 3. So our next point is 2, 3. 2, 3. Last but not least, 3 squared minus 1. 3 times 3 is 9. The only reason I left that space, guys, is for you guys to write it in if you wanted to, okay? But I can't baby you all the time. 3 and 8. No, let's connect them. Oh, by the way, what I wanted to show you is if I wanted to connect all of these dots, there's no way that I can use a ruler to hit them all at once. Okay, with the linear, I could go through every single dot without even touching my ruler after I have it placed. Not the case here. I'd have to connect those two, then those two, then those two, then whip it around. And that's another reason why I know it's not linear. Okay. Okay, so it's quadratic because we just did it and we can't connect it with a ruler. I don't know if you guys noticed, there's a bit of a pattern here. Those two numbers are the same, and those two numbers are the same, and those two numbers are the same. Should have happened up here too. 9 and 9, 4 and 4, 1 and 1. That's a good thing. Okay? Ugh, I always do that. Okay, so remember, first differences, these should not be the same. If they are, then we have a linear function, but we don't. We know we have a quadratic because A of this squared, and B because I just drew a U-shaped, really crappy looking U-shape, but that's okay. So 8 minus 3 is equal to 5. 3 minus 0 is equal to 3. Okay, they're not the same. Good start. 0 minus negative 1 is positive 1 because a negative and a negative is a positive. Negative 1 minus 0 is negative 1. 0 minus 3 is negative 3. And 3 minus 8 is negative 5. If you guys are wondering why I'm doing subtraction, differences means subtraction. Okay? That's why I'm doing subtraction. Second differences. Now, we want all these numbers to be the same. If they're not, we messed up. 5 minus 3 is equal to 2. 3 minus 1 is equal to 2. 1 minus negative 1 is equal to 2 because this becomes a positive. Negative 1 minus negative 3 is equal to 2 because of this. And believe me or not, that happens to be a 2. For that being a 2, it might not be a 2 every time. I know our last example we did 2s as well. Okay? So, last thing I'm going to go through with this note particularly is we're going to introduce you to some characteristics. And then the next note, I'm going to go into more detail about them. So the parabola so the graph of a quadratic relation is called the parabola. The parabola has some important features, and this is all stuff that you guys are going to have to know and learn how to solve, because that has to deal with our word problems. So the parabola can open up or down. So right now, see how many colors I can get. My parabola is opening up. Okay? It's opening up. If it was down, it would look like this. Oops. Which is possible. Okay? Oh, I lied to you. Right now it's opening up. And down would look like this. The zero of a parabola is where the graph crosses the x-axis. The zeros are also called the x-intercepts or the roots. Okay? So this is what we were doing when we were factoring. It's when it crosses the x-intercept. So we find that out by factoring. So we determine what the zeros are by factoring. The axis of symmetry divides the parabola into 2 equal halves. Okay, so if you haven't noticed by now, the parabola goes all the way one way and then it goes to the next. Okay, sorry, I explained that really bad. It goes all the way down and then it reverses and goes all the way back up in the exact same way. So that is my axis of symmetry. The vertex of a parabola is the point where, so the vertex of the parabola is the point where the axis of symmetry and the parabola meet. It is the point where the parabola is at its max or min value. So our max or min is the highest or lowest point. So in this case, would this be my max or my min? Would be my min because it's the lowest point, right? The optimal value is the value of the y-coordinate of the vertex oops. So the y value is the optimal value and again, I'm going to go in more detail about this with the next unit, or the next lesson. Is the y-coordinate of the vertex, and the y-intercept of the parabola is where the graph crosses. And we've done the y-intercept before, and that was when we were doing y is equal to mx plus b. So is where the y-intercept of the parabola is where it crosses. In this case, it's here. So I'm sure you guys are like, oh my god, that was really overwhelming. That was a lot of things we just went over. Yeah, you're right. It was. But I'm going to go into more details about this the next note, okay? So it's going to be a bit of a longer note, but I'm going to go through these in detail, and then we're going to get into word problems that teaches us how we can start reading that stuff. Alrighty, guys? Okay. See you next note.